So I've been using this ceiling lamp here for roughly 5 years now, and since I still do like its overall design and features, I want to continue using it. But there's just a small problem. Instead of the classical G4 halogen light bulbs, which consume 10 watt each at 12 volts, so 60 watt in total, I wanted to use those G4 LED light bulbs. They may not produce as much light as the halogen ones, but with a power consumption of only 2.1 watts each, they can save me 47.4 watts of power in comparison. That is quite a bit. So obviously I replaced the old light bulbs with the LED ones. But after turning the lamp on, they would not light up as bright as with a normal 12 volt power source. So the question is, can we fix it? Let's find out. First off, I removed one LED light bulb in order to measure the voltage at the sockets, which seems to be around 3 volts AC, way lower than what the label of the built-in transformer claims. As an additional test, I reinserted the old light bulbs and removed them one after the other while measuring the voltage as well. The result was that the voltage decreases with lower loads, until it reaches an open circuit voltage of 5 volts AC. Which actually shouldn't have been a surprise since the transformer is rated for a minimum load of 35 watts. But how can we draw the remaining 22.4 watts in order to power the LEDs properly? The easiest fix would be a power resistor in parallel to the light bulbs, but not a puny one like this. We would need a 5.9 ohm 22.4 watt resistor. This 5 ohm 50 watt resistor from China should work just fine, but it would also decrease the efficiency of the lighting system to 36%, which would be stupid. Another solution would be to modify the utilized transformer, but because the insides of it look more complicated than what I initially expected, we would only lose a lot of time trying to figure out how to modify it. So let's throw the transformer out of the circuits and replace it with the 12 volt power of my lab bench power supply. Since the one output wire connects directly to one side of the sockets and the other one to a small box which contains a relay that connects the other wire to the other side of the sockets, it should work just fine, which it actually did. So I went ahead and ordered a new 12 volt power supply which does work with loads from 0 to 30 watts. And even though it is DC instead of the original used AC, it works fine in the circuit, even with the halogen light bulbs. But we are still not done with the optimization. There is a third box inside the lamp, which is a 12 volt DC power supply that powers the 5mm LEDs of the lamp, and most importantly the control electronics, aka the circuit with the relay I talked about earlier. And because my new power supply does deliver 12 volts DC as well, we can simply remove this one, pinch off the main input wires of it and connect its output power wires in parallel to the wires for the light bulbs, through the help of Wago terminals. After storing the control circuit in its case and securing the two boxes inside the lamp with a bit of all-purpose adhesive and tidying up the wiring, this lamp was officially fixed and will hopefully work for a couple more years. I hope you liked this video. If so, don't forget to like, share and subscribe. That would be awesome. Stay creative and I will see you next time.